The producers and distributors of Tech AV audiovisual training aids welcome you to this, the second program in the series on the subject of compressed air systems. This is Module 2 in the series, in which we shall look at reciprocating compressors and maintenance procedures. We shall begin with an overview of compressor construction and operating principles. There are basically two commonly encountered types of reciprocating compressor, namely single-stage units and two-stage units. Although they appear to be very similar, you'll see shortly that there are some important differences. This small unit is an example of a single-stage twin-cylinder compressor, and, as you see, it has two equal-sized cylinders. By comparison, this two-stage unit also has two cylinders, but you'll notice that the cylinders are not the same size. In fact, the larger cylinder is double the size of the smaller. We shall explain the reason for the differences shortly. Let us learn to identify the parts of a common compressor before we move on to describe the operating principles. The major moving parts of all reciprocating compressors are practically the same, and they include pistons, connecting rods, and a crankshaft. All the moving parts are contained within a cylinder block or crankcase. The pistons fit into their respective cylinders, and as the crankshaft is turned, the connecting rods force the pistons to move up and down within their cylinders. The crankshaft is supported at either end, in this example, on bush-type bearings. A flywheel is attached to the end of the crankshaft. The flywheel also acts as a belt drive pulley and a cooling fan. In this semi-assembled condition, the compressor cannot compress air because the cylinders are totally open. Each cylinder must be enclosed in order for the compressor to pump air. Situated at the top of each cylinder, there will be the following components: a gasket, a valve plate, a valve unit, which in this assembly is called a feather valve assembly, a second gasket, which is a very important part of the whole valve system, and a head or cover plate. All of these items are secured to the cylinder block with set screws. We have now identified all the major parts of a typical reciprocating compressor. Having identified the major parts, we can now overview the basic operating principles of single-stage and of two-stage compressors. All reciprocating compressors operate in a similar manner. They all use one or more pistons to pump air pressure into a system. In fact, you will often hear people call these compressors pumps. As the crankshaft is driven by the drive motor, the rotating motion of the crankshaft converts into linear motion of the piston. The head end of the cylinder is closed, and the piston compresses the air between itself and the closed end of the cylinder, sometimes called a cylinder head. When the piston moves down inside the cylinder, a suction effect is created, and this results in the opening of a suction or intake valve. Air from the atmosphere now enters the cylinder and fills the space above the piston. When the piston moves up inside the cylinder, the air above it is forced into a smaller and smaller space, which results in a rise in the pressure. This, in turn, forces the inlet valve to close and to block off the passageway to the atmosphere. Further movement causes more pressure to be generated, which in turn results in the opening of a discharge valve. Single-stage compressors discharge their compressed air directly into the system or into a receiver. In other words, full compression is achieved after one upward stroke of a piston. Single-stage compressors are usually quite small units, such as those used in small workshops or for home use. Where large air quantities are required or higher pressures need be generated, then a multi-stage compressor would be more practical. A very common type of multi-stage unit is a two-stage compressor, so called because the final delivery pressure is generated in two stages. A two-stage compressor is identifiable by the fact that the unit has cylinders of different sizes, large cylinders called low-pressure cylinders, and smaller cylinders called the high-pressure cylinders. The high-pressure cylinders are in fact half the size of the low-pressure cylinders. Air is drawn from the atmosphere via an air filter into the low-pressure cylinder, where it is compressed to a relatively low pressure, typically around 3 or 4 bars, that is to say 45 to 60 pounds per square inch. This air is then discharged through an intercooler and then fed into the intake side of the high-pressure cylinder. Final pressure is achieved in the high-pressure cylinder, where the air is discharged into the system or the tank. An intercooler is usually simply a copper tube that has air fins soldered onto it. The air fins act to draw heat out of the copper and to present a large surface area over which outside air will flow. The reason for this is to do with cooling. You will notice that the cylinders and the heads of most reciprocating compressors are heavily finned. In the process of compressing air, mechanical energy is converted into pressure energy. A great amount of heat energy is generated in this conversion process. The hottest parts of a compressor are where the compression takes place, namely in the cylinders and the head area. To keep the compressor cool enough to operate without seizing up, outside air is caused to blow across the outer surfaces of the hot parts. The flywheel acts as a forced draft fan and directs large quantities of air over the cooling fins. The fins effectively create a large surface area, and this offers better cooling or heat transfer into the atmosphere. This concludes part 1 of the module. In the next section, you will learn how to perform basic maintenance tasks.